累到很凉。
So hello everybody. Today we're doing some combustion reactions, which are very important reactions in the scheme of things, but they're a little bit difficult to balance. All right, so the essential questions are: what are the unique details when a fuel is burned in the process called combustion? What are typical hydrocarbon fuels? How is human respiration related to combustion of fuel outside the body? And what does the photosynthesis reaction show you? All right, so here's a typical one. Combustion reactions are primarily about covalently bonded compounds as fuels. All right, keywords: covalently bonded. So we're thinking of nonmetals. All right, so when you look at these, you'll see CH4 is made of carbon and hydrogen, both nonmetals. This is a gas fuel used in Bunsen burners. All right, so the first thing we have to do is finish the reaction, because most of these below don't tell you what the product is. So if there is complete combustion, we get a blue flame with methane, and we only get invisible carbon dioxide and invisible H2O. Okay, now, is this equation balanced? Well, let's see, 1 carbon, 4 hydrogens, 2 oxygens. This is the order in which we usually count in combustion, because the oxygen are the ones we fix up at the end to make it work. So this one has 1 carbon, 2 oxygens, then 1 oxygen over here, and 2 hydrogens. So the next thing that we balance after carbons, 1 carbon on each side, is hydrogens. There's 4 here and only 2 here. So the only way to get more hydrogens is to put the coefficient 2 in front of water, and now we have 4 hydrogens, but now we have 2 oxygens right there, which means now, just in that one thing that we changed of the number of water molecules, we now have 4 oxygens. All right, so carbons are taken care of, hydrogens are taken care of. Let's see, we have 4 oxygens on the product side. Over here, we only have 2 oxygens, right? So if we put a 2 coefficient in front, that makes 4 oxygens. 4 oxygens, we have balanced this equation. And the coefficients are 1 CH4 molecule, 2 oxygen molecules, 1 carbon dioxide molecule, and 2 water molecules. These are all listed as gases, you notice, because at the temperature of combustion, water is water vapor, and CO2 is always a gas. All right? So, all of the both reactants and both products are gases. Yes, we did get this to balance. All right? So the rule of thumb is count carbons first, hydrogen, then oxygen. So let's go down here and work on ethane. Now we asked, what kind of molecules are used as fuels? Well, notice C2H6, C3H8, C4H10, C5H12. So see how we have hex, pent. In this case, butane means 4. All right? Now, so these are the kind of things that are hydrocarbon fuels. Let's go to this one. Let's go to ethane right here. And I'm going to do another example balancing. Because we said up here, let me see where we said it. Oh. All right. It looks like this thing got moved. All right. So we'll come back and use it in a second. All right. Now, ethane, C2H6. So C2H6 plus O2. Combustion always takes oxygen out of the air. And if this is complete combustion, it's CO2 gas plus H2O gas. A lot of times, complete combustion doesn't happen around a campfire. The campfire isn't hot enough, and so we see those little black particles in the air. So a yellow flame, remember, is a cooler flame. The flame of a Bunsen burner is blue because it's the hottest, and that's what gives you complete combustion. All right, so let's begin our task. We're going to first count carbon. All right. So we have, are you okay, honey? All right. Do you want a drink of water? Oh. All right. So we have 2 carbons and we have 6 hydrogens. All right. Now, let's go over here to the other side. We have 1 carbon and we have 2 hydrogens. So now we see that we have 2 carbons here and only 1 here. So in order to get 2, we have to bring that 2 up here as a coefficient. And now that gives us 2 carbons, but it gives us 4 oxygens. And then we have 6 hydrogens, and we have to get all the hydrogens from over here, don't we? There's no other source on the product side of hydrogens. So now we have 6 here. But we also have 4 here, don't we? Oh. All right. So we have to add those together. These are from water. The 6 are from, excuse me, this is 3. I misspoke. I'll show you what I did. Yeah. Now we have 6 hydrogens. That's what I hadn't done. But we have 3 oxygens over here, plus the 4 that are over here. 2 CO2 molecules would give you 4. So altogether we get 7. All right, so things are okay. We have the carbons balanced, the hydrogens balanced, but we need 7 oxygens. And how do you get 7 oxygens when you have an O2 molecule? So here's what we do. We put 7 halves. So 7 halves of a diatomic molecule. Well, it isn't okay. So let me go up and get this little thing that disappeared. Let me go see. Here it is.
Right.
All right, let's bring that down here. All right, we need 7 oxygens on each side. But we can't get 7 using O2 without the fraction. So double all the coefficients. So we're going to go and double everything that we have already.
Okay.
All right, so we had 1 here, and now we have 2. We had 7 halves here, and now we have 7. We had 2 here, so now we have 4. And we had 3 here, so now we have 6.
Oh.
All right. And that's how we were able to balance one that when we first balanced it, we had to put a fraction. So we aren't supposed to use non-whole numbers. for coefficient. So this is like 3.5, right? Yeah. 3.5 O2 molecules would give you 7 oxygens. So whenever that happens, that you have a fractional coefficient, you go through and multiply it by this number on the bottom, 2. So we double everything, so we get 7 O2 molecules, 2 C2H6 molecules, 4 carbon dioxide, and 6 water. All right, and that doubles all of them. All right, so that's the basic pattern. You've seen a simple one like this, CH4, and then we did a harder one where we end up having to double everything. Now, I want to show you this. Let me bring this down here. Something happened to my page, it looked like. All right. No, I can't. Just a sec. So, we'll notice a pattern in the even-numbered hydrocarbon fuels, such as C2, C4, C6. So it was ethane that had an even number of carbons that ended up with this pattern that we have to go back through and double all the coefficients. All right. So as you start on this one, propane plus oxygen, you have to remember that the products of complete combustion are always going to be carbon dioxide and water. All right. Thank you.